fell into a burning ring of fire. I went down, 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 and the flames went higher. And it burns, 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 the ring of fire, the ring of fire.
All right, welcome back. Parallel lines and triangles. So we got a postulate. Remember, this is something that you just kind of have to accept as true. We can't really prove it. It's one of the basics of geometry. Through a point, not on a line, there is one and only one line parallel to that given line. So if we take a look at it, what's that saying is this. Let me get a line up here. If we have this line right here, boom, there's only going to be one line through that point that's parallel. If I have another line that goes through there, you know, that's a little bit exaggerated, but no other line will be parallel to this line and through that point. There's only going to be ever one possibility for that, all right? Just one of those things that, you know, it kind of makes sense when you see it, but we can't really prove it because it's a postulate. All right, so today we're going to talk a lot about triangles and the angles related in there. All right, so what are the angles? If I added all these angles up, 1, 2, and 3, what would this sum be? Well, we could, you know, measure those and get them out, but let's take a look here. So this is angle 2. I'm going to try and rotate this. This hopefully will work. All right, you know, sometimes these things, I have this great idea and then they never see like that. Okay, we'll get it right there. It's close. And then bring angle 3 over here. Line that up. Okay. So we have angle 1, 2, and 3. Now, this makes a straight line right there. It's hard to tell. Let's make sure. Straight line through there. So how many degrees are in a straight line? How many degrees in a straight line? Well, we know there's 180, so it looks like there's 180 degrees in angles 1, 2, and 3, which sounds like a theorem. It's the triangle sum theorem. It's a big one. All right, the sum of the measures of the angles of a triangle is 180 degrees. Any triangle you have, the sum of these three angles is going to add up to 180 degrees. 180, huge number in geometry, right? It's come up several times already, supplementary and all that stuff. So this is another time it comes up big. So it's great because now we can write more equations. I know it's your favorite thing ever, writing equations. So we can find the missing angle here. We know that 42 plus 95 plus this third angle is going to equal 180 degrees. All right, 42 and 95, that's 137. 137 plus what equals 180? 130, well, that will be 43. So the missing angle here would be 43 degrees. All right, let's prove this. Given that we have this triangle and we have this line parallel to this line, we want to prove that the angles inside measure 180. So number one, let's start with the given. Triangle XYZ and YA parallel to XZ. That is given. All right, number two. Let's talk about this. This here's a straight line, that's 180 degrees, but we can't just say that. So we have to pair some things up because a linear pair is 180. We have three, not a pair. So let's group these two angles together. So angle AYX and angle 4 are supplementary. All right? And that's angles that form a linear pair are supplementary. Okay? So we now have this and that equals 180 degrees. All right, so let's see here. So, well, we know that's 180 degrees, like I said, so let's write that out. So the measure of angle AYX plus the measure of angle 4 equals 180. And that's just the definition of supplementary angles. Okay? Number 4. Let's see here. Now what is AYX? AYX is 5 and 1 together, right? So we should write that down. Angle AYX is angle 5 and angle 1. And whenever we add angles, that's the angle addition postulate. Okay? All right, so now that we have that, what else can we do? Well, we know that this is 180 degrees. Let's substitute in. So let's do the measure of angle 5 plus the measure of angle 1, because that's AYX, plus the measure of angle 4 equals 180, and that is substitution. All right. So now let's take a look at this. Angle 5. Angle 5, these are parallel lines, so angle 5 and angle 3 are congruent. They're the same. So the measure of angle 5 equals the measure of angle 3. And also, angle 4 and 2. Measure of angle 4 is equal to measure of angle 2. And the reason for that is because they are alternate interior angles, right? So if two lines are parallel, then alternate interior angles are congruent. All right, that's awesome. So now let's plug these in. Instead of angle 5, let's put angle 3. So the measure of angle 3 plus angle 1, we didn't have any change for that, plus angle 4 is angle 2, equals 180 degrees. And that's what we wanted. 1, 2, and 3 equal to 180. And all we did there was substitution. All right? That's how you do that proof. I know it's a little long and complicated. You often don't see it, all right? I understand that proofs are tough. We're going to do a lot of them this year, so you're going to get used to it, okay? Just hang in there. Let's try this one. Again, we have 3 angles in the triangle. We know that all 3, every time, regardless of what kind of triangle it is going to add up to 180 degrees. So 76 plus 47 plus 6x minus 9 is going to equal 180. All right? 76 plus 47 minus 9, I believe, is going to give us 114 plus 6x equals 180. Subtract 114 from each side. 6x is going to equal 66. Divide by 6. X is 11. All right? So that's a huge theorem, all right? Every triangle you see is going to equal 180. Check this out. I could divide this up right here. I have this triangle and the big triangle. All of those will add up to 180 degrees when you add the angles. So this angle plus this angle plus this angle is still going to be 180 degrees. It's really cool. All right, so now it's going to take us to exterior angles. The exterior angle of a polygon, now we're going to talk mostly about triangles today, but a polygon is an angle formed by a side and the extension of an adjacent side. So let's say a polygon. Let's say I have a square or a rectangle. Whoa. So I have a side, and then this side I'm going to extend it out. So this right here would be our exterior angle. All right? In a triangle, think about it this way. If I extend that side here, that's an exterior angle. Okay? A remote interior angle is a non-adjacent angle to an exterior angle. In a triangle, there are only 2 remote interior angles. So if this is my exterior angle, this angle here is adjacent, right? And we can't have that. So it's the 2 ones that are inside but not adjacent. Remote, they're farthest away. So again, here's another example. We could have it here. It's not this angle, it's the other 2. And of course, it could have on the third side. Our remote interior angles. It's kind of nice because now we have another theorem. It's called the triangle exterior angle theorem. And that is the measure of each exterior angle of a triangle equals the sum of its two remote interior angles. So if I have angle 1 here, that is going to equal the sum of these, 2 plus 3. All right, let's try one. So I have my remote exterior angle here. I know that's 93, and it's going to equal the sum of those, x plus 34. So I can find this because subtract 34, and x is going to be 59 degrees. All right? You could see you have three things here. You could have any of them be missing. You could have both remote interior angles and find the exterior one. Any way possible. All right. All right. Let's find this one. This one is massive. Try this. Find the value of all the variables in this diagram. All right. So we have a ton of stuff in here. The thing I like to do when I get a problem like this is start with the easiest things I know. I know I look for straight lines. Here's a straight line. Boom, 180 degrees. So C in 155 has to equal 180, right? So C plus 55 has to equal 180. That means C, if I subtract 55, C is going to be 125. Now the next thing I like to do is I like to actually label that stuff in my triangle. All right. Now check this out. I have a triangle right here. And how many degrees are in a triangle? I know that there are 180 degrees. So D plus 125 plus 32 is going to equal 180. All right, so if I subtract 125 and subtract 32, I'm going to get, I think that is 23 degrees. So D is going to be 23 degrees. All right, I'm going to label that right there. Okay, let's see, what else do I know? Well, this is a big symbol here. What does that symbol there mean? That symbol means it's a 90-degree angle, right? So if that's 90, B plus 32 has to equal 90. So subtract 32, and B is going to equal 58 degrees. Plug that in. And I have another triangle right here. How many degrees in a triangle? Well, there's 180. So 55 plus 58 plus A is going to equal 180. Add 55 and 58, subtract it from 180, and A is going to equal 67 degrees. Right there. And last but not least, we have E out here. Well, that's an exterior angle, so it's the sum of these two right here because it's the big triangle. So 23 plus 67 equals E, and that is 90. 90 degrees. All right? So while that problem looks really big and horrible right from the get-go, just take it one step at a time, all right? Find one thing, then find the next thing, okay? Take a second, pause the video, and you try these. All right, so welcome back. So how many degrees in a triangle? 180, so 74 plus 42 plus what equals 180? Well, that's going to be 116 plus what equals 180? Should be 64, I believe. So that one's going to be 64 degrees. Here I have an exterior angle, so the exterior angle equals the sum of the two remote interior angles, x minus 3 plus 5x plus 4. So 131 equals 8x plus 5x is 13x. Negative 3 plus 4 is 1. Subtract 1, I get 130 equals 13x. Divide by 13, and x equals 10. All right. So there you have it. Here's one of my... Here's a really corny, right up Mr. Kelly's alley. He probably tells this joke every day in class, but it's a classic geometry joke. Hope you enjoy it. Good luck on the master check. Boom!
Conversation. Jake, if you're finished, just go do your homework.
I'm gonna need help.
You don't need help, you need to focus.
I'll help you, Jake. You know anything about geometry? Well, I know it's what you say when you turn into a tree. Get it? I'm a tree.
Boy, I hope when they get to Oz, the wizard has 2 brains to give out.